So the last one which we are left with, silicon dioxide or silicon 4 oxide, that is the last example of giant covalent structure. If you look at the structure over here, isn't it same like diamond? In diamond, if you recall, there are all 4 carbons which are bonded like this. And here, if you see, there is a silicon and there are oxygen, but the structure is same. The arrangement of atoms are same, right? So that is the similarity between diamond and graph and silicon 4 oxide, that they have a same structure, which is tetrahedral arrangement of atoms. And each silicon atom forms 4 covalent bonds with 4 oxygen atoms, as you can see in the diagram. And each oxygen atom forms 2 covalent bonds with 2 silicon atoms. And there are strong covalent bonds throughout the giant lattice. That's why its melting at boiling point is high. And it's the main compound of a sand and found in a naturally occurring mineral which we called quartz. There are no free electrons, hence it does not conduct electricity. It is used in sandpaper. It is used to make glass and bricks, which are used for lining the furnaces, because in furnaces we have to maintain a very high temperature. So as its melting point is very high, so it is actually stable at very high temperature. So that's why on the inner lining we place the bricks of silicon oxide, so it stays stable. Okay, note these points down, then we will start with the past papers.
Sir,
Yes, Khatija.
sir, I didn't get the third point that each oxygen atom forms 2 covalent bonds with 2 silicon atoms.
See, there is one oxygen. It is getting bonded with one silicon over here and one silicon over here. And if you look at silicon, that silicon is getting bonded with 4 oxygens, one here, one here, one here, and one here.
Okay, sir. Okay.
क्लास में ना बोलो बिल्कुल अभी क्लास ले रहा हूँ Okay. Khadija, are you done as well?
Yes, I'm on the last point. Almost done.
Okay.
Then
Okay. Now have a look at this question. Explain why solid carbon dioxide does not conduct electricity. So if it is not conduct electricity, what could be the reason?
because they do not have free electrons or ions.
There are no free moving electrons or ions. Is this understandable? Now, they have mentioned over here that silicon 4 chloride has a simple molecular structure. Predict one physical property of silicon chloride at room temperature. Yes, if it's a simple molecular structure, can tell any one physical property.
It has
Check, check the physical properties of simple molecular substances.
they have low melting and boiling point.
Sorry,
They have low melting and boiling point.
they have a low melting and boiling point, and beside this, they do not conduct electricity.
Yes.
So you can write any one point. Sir, Zainab is not here.
So Zainab, same
Hmm?
same Zainab Kushi same.
Yes. So you can write any one of the property, whether low melting point or whether it does not conduct electricity. Does not. Just recall me, so I will share all the notes. Ethanol is a simple molecular compound. Explain why ethanol does not conduct electricity. So what will be the answer? If it does not conduct electricity,
Uh, Again, it will not have the free moving electron.
yeah, there are no free moving electrons. Okay. Now, ethanol can be dehydrated to form ethene, and they have mentioned you the formula of ethene. It is C2H4, right? Describe using a dot and cross diagram the bonding in the molecule of ethene. So who can do it? Draw it quickly. Take the help of the periodic table. Include the outer shell electrons only. Yes, Khatija, are you drawing?
Yes, sir.
Are you done? Let me see. Assalamu alaikum, Zainab.
Alaikum salam.
Electrons on carbon will share. Think of how many electron squares a shell of carbon have and how many electrons it can share. Yes, how are you, Zainab, and why you are not coming?
Sir, I'm good. वो card issues और इसलिए नहीं आ रही.
Okay. So have a look over here. If you look at a carbon, carbon is from group. Yes, carbon is in which group? So how many electrons it have in it?
Four.
So how many it will share? 4. So you shared only 2. So each carbon need to share 4 electrons, right? So when each carbon share 4 electrons, the structure is going to be like this. There is a two pairs of electron between 2 carbon atoms, one pair with one hydrogen, one pair with the other hydrogen. So if I have to show the bond, there is going to be a double bond between 2 carbon atoms and a single bond between carbon and hydrogen atoms. Is this understandable to all of you?
Yes, sir.
Yes, Zainab?
Yes, sir.
Okay. Now, see this one. We have discussed there are only 3 giant covalent structures. One is scarified, one is carbon, and one is silicon dioxide, SiO2. So you have to remember that which are giant covalent. So in the similar way, state they have mentioned you the formula over here and asking you the structure and bonding. So we know that it's a giant, not a simple. I have just mentioned over here at the top the other options that can be used to write. So if it's SiO2, the structure is giant and the bonding is covalent. For example, instead of this, they have asked you NaCl. Then structure is again giant and the bonding is going to be ionic. For example, if they ask you CO2
Ionic.
for CO2 and weak intermolecular forces. So that's how you will answer these kind of questions. Is this clear? Yes, Khatija and Zainab?
Yes, sir.
Okay, now how we will answer question number 5. They have told you that it's have a low melting point. So which structures have a low melting point, giant or simple?
Simple.
Simple. So in terms of structure, for structure we will write simple molecular and simple covalent molecule, and for bonding we will write weak intermolecular forces between the bonds, between the molecules, sorry. Is this understandable? Yes, sir.
Yes.
Okay. Now, see here. Now that is a question where they are asking you a comparison. They have shown you carbon dioxide and calcium carbide. Here you see there are simple molecules which are further apart from each other. And if you see over here, here we have, which particle we have? But if it's a charged particle, then what we call it?
Ions.
Ions, right? So they are asking, explain in terms of structure and bonding why carbon dioxide has a low boiling point and calcium carbide has a high boiling point. So the reason is that simple. First, you will mention about the structure, that carbon dioxide have a simple molecular structure and calcium carbide have a giant ionic structure. Then you will compare the bonding, that there are weak intermolecular forces of attraction between CO2 molecules, which makes its melting point low, boiling point low, and there are strong attractive forces between ions throughout the structure that makes a higher boiling point of calcium carbide. Is this clear?
Yes.
Yes, sir.
Okay. Then They have mentioned you that graphite conducts electricity. They are asking one other reason why graphite electrodes are used in electrolysis. So the other reason is that it is inert. It do conduct electricity, but it does not take part in the reaction. It just provides electrons for the electricity only. So we will write that it does not react. It is inert. Is this clear? Yes, Zainab?
Yes, sir.
Okay. Then now who's going to answer me this one? Explain in terms of structure and bonding why sand has a high melting point. Sand.
Because it has a giant covalent structure
Very good. Giant covalent structure. And
and
yes, what about bonding? Yes, Manahil, how will write?
they are strongly bonded like one.
Strong covalent bonds throughout the
They
structure.
have strong forces of attraction.
Yes, strong covalent bonds throughout the structure, hence large amount of needed energy is needed. So you guys are not recalling the things. Now, who will answer me this? They have mentioned you the formula and the name of compound, which is titanium 4 chloride, and they have told you it is a colorless liquid and has a low boiling point. So it is the structure and bonding. Yes, what kind of structure it has? Yes, simple molecular structure,
Simple covalent.
simple covalent structure. And what about the bonding? Yes, Zainab.
It will be weak.
Yes, weak intermolecular force.
Intermolecular forces between the molecules. Is this clear?
Yes.
Yes, Zainab and Khatija. Now have a look at this.
Yes,
Yes, sir.
The structure of silicon dioxide.
Yes, sir.
yes, clear.
Describe two similarities in the structure of silicon dioxide and diamond. They are talking about the structure. One is the tetrahedral arrangement that we have seen in the previous class. In diamond, it's same.
Tetrahedral.
And the other one is either you can write both have no free electrons, or both have a covalent bonds, or both have a giant structure. You can write any out of these two. Any two. Yes, is this clear? Yes, Zainab.
Sir, can we also write that at the center they both have the carbon atom?
No, here there is no carbon atom, it's a silicon.
Yes, sir.
Carbon atom is only in diamond and graphite, not in silicon dioxide, okay?
Okay, okay.
Why silicon dioxide has a high melting point? Which kind of structure it has?
Because it's a giant.
Giant covalent. And
Because
Giant
it has a giant structure.
yeah, giant covalent structure and strong covalent bonds throughout the structure. So see, you have to write the answer in this manner to get the whole marks. Yes, Manahil? Is it clear? If you have any confusion, do ask. Zainab and Khatija? Is this clear?
Yes, sir, clear.
Yes, sir.
Okay.
Yes.
You have to reduce the molecular formula. How you will do it? You have to count the atoms of each element and then write the formula. So how many carbon are there? 4. How many hydrogen are there?
5.
No, not 5. 12. 2 oxygens and 1 silicon. So that's how you will write the.
12.
Okay. Is this clear? Okay. Now have
Yes.
question. Some properties of group 6 elements are shown. We have oxygen, sulfur, selenium, tellurium, and polonium. Use the information in the table to explain how the structure and bonding in oxygen differs from the structure and bonding in polonium. So if you see oxygen, its melting point and boiling points are very low. And if you look at polonium, it have a high melting and boiling point. If we look at the electrical conductivity in solid, it conducts electricity in solid and it is very poor. So if it is conducting in solid, so it means it's a metal. So there is a giant metallic structure for polonium. And they have a low melting point. Oxygen, it means there are simple covalent molecules of oxygen. Then there is a weak intermolecular forces between oxygen molecules and there are strong metallic bonds throughout the structure in polonium. So that's how you will compare it. Yes, is this clear? Yes, Khatija and Zainab, is it clear?
Yes.
Yes, sir.
Okay. So
Yes, sir.
Yes, sir.
next we have metallic bond.
Yes, sir. I have a question.
Yes. Yes.
Sir, in ionic bonding, they only conduct electricity when they are in molten form.
Or
Right.
aqueous form. When they are aqueous or molten, they conduct electricity, and that is due to the movement of, you know, ions of electrons. Okay.
Okay.
So you have to know this difference. Metals conduct electricity in solid, and due to the movement of electrons, and ionic compounds conduct electricity when they are either molten or aqueous, and due to the movement of ions. Now we have a metallic bond. So when we talk about metallic bonding, so this bond is present in the atoms of metals, and sometimes you will observe in alloys as well, because alloys are also a mixture of metals. So that is how we define metallic bonding, that it is an electrostatic force of attraction. Why electrostatic force of attraction? Because opposite charges are attracting each other. Between cations, what are cations? The ions which have positive charge. And C of delocalized electron, whenever we use the term delocalized, it means that which are movable, which are freely moving. So instead of delocalized, you can also write free moving or mobile electrons. And here we have the structure of metallic bond. This structure shows metallic bonding. And sometimes examiner asks you to show the structure of a metal or show the metallic bonding. So you will draw this structure, okay? Note down this quickly. Assalamu alaikum, Rahma. So, if you look at the structure, see, these spheres with a positive charge are cations or positive ions, and the dots over here are electrons. And we know what charge electrons possess?
Negative.
Negative charge, and cations have positive charge. So remember, these cations are actually mobile, are actually fixed in the lattice, they do not move. Okay. But when we talk about these electrons are mobile, means they are free to move or they are free moving. So what happened when this electron travel in the spaces between those two cations? In actual, if you see, the cations have a positive charge, so they have to repel each other. But there is a particle in between over here, which is negatively charged and which is moving in the space between them. So what these cation will do, instead of repelling each other, they start attracting that negatively charged particle. And as they attract this negatively charged particle, they stays together, and that makes a metallic bond. Is this understandable?
Yes.
Yes, Khatija?
Sir, can you explain it again?
Yeah. For example, have a look over here. This is a one cation, this is a other cation, then we have another cation and this cation, and here we have an electron which is negatively charged. So when it moves randomly in between the spaces between the cations, so what will happen? Instead of repelling each other, they start attracting that negatively charged electron, right? Yes, Zainab?
Yes, sir.
So if they start attracting these negatively charged electrons, so as a result, they stay together. And this attraction between the free moving electron and these cation is called metallic bond. Is this clear now?
Yes, sir.
Okay. Is everybody done till the diagram?
Yes.
Okay. Now, these are the properties of metals that usually examiner asks. So first understand, then note it down. The first one, you need to remember that metals have a giant metallic structure or giant metallic lattice. If they have a giant metallic structure or giant metallic lattice, it means their melting point and boiling point are very high. And why? The reason is that there are strong metallic bonds throughout the structure, and due to these strong metallic bond, a lot of energy or a large amount of energy is needed to overcome these bonds. So instead of writing metallic bonds, examiners sometimes mention this whole thing. So either you can write this whole thing, that is strong electrostatic forces of attraction between cations and mobile electrons, or instead you can use this term metallic bond, both means the same. Okay. So whenever examiner mention any metal and ask you to why it have a high melting point or why it have a high boiling point, so you will answer it in that way, that it's that metal have a giant metallic structure, and in that giant metallic structure there are strong metallic bonds throughout the structure, or instead you can say there are strong electrostatic forces of attraction between cations and mobile electrons throughout the structure. And that's why we need a lot of energy to overcome these bonds or these forces of attraction. The second property is they are malleable. Malleable means they can be bent and pressed into shapes by applying external force. And the next thing is that they are ductile, which means they can be drawn into wires and thin sheets. And why they are malleable and ductile? Because when we apply the force, the layers of atoms or a cations can slide over each other. So if you look over here, this is the structure of a metal. When we applied the force in this direction, in that particular area, so these layers are actually slided. See, the layers which are at the bottom stays at their position, but the layers which are on the top where the force is applied are actually slided. So due to this sliding property of layers, the metals becomes malleable and ductile. Is this understandable to everyone?
Yes.
Yes, Khatija, Zainab and Rahima.
Yes, sir. Clear.
Okay, note this down quickly. And just give me 5 minutes, I will be back. Yes, is everybody done? Yes,
No,
Zach?
sir.
Okay, do it quickly. Yes, everyone done?
Yes, sir.
Yes.
Okay. Now, the next property that metals have, that metals are good conductor of heat and electricity, and it is because they have a free moving electrons which are present in their lattice. So after discussing these properties, we are going to start the metal. Okay. Yes, everyone is done?
Yes, sir.
Okay.
Sir,
Okay, then.
Done.
Rahima, are you done? Okay, before heading towards further discussion about metal, have a look at the periodic table. And if you recall, I have already discussed these elements which are on the left side of this staircase are the ones which are what?
Metals.
Which are metals. So these all are metals, and these all along with hydrogen are non-metals. So we are going to discuss about metals. So let's start. So here we go. Examiner ask you to draw the structure of a metal and alloy. Metals, the structure of metal you have already drawn. It is like this. For alloys, you have to draw the structure like this, which shows a little irregular arrangement and along with the different size of atoms as you have seen. So if you recall alloy is a mixture of a metal with other metals and non-metals. So it is not necessary that every time alloy contain all the metals. Do remember alloy also contains non-metal sometimes along with those metals. So we have two examples of alloys over here. Stainless steel, which is made up of which is a mixture of iron, chromium, nickel, and carbon, and the other one is brass, which is zinc, which contains zinc and copper. So you must remember the composition of these two, which is important for the exam. Okay. When we talk about the strength of the alloys, we know that metals are strong, but alloys are even more stronger than metals. They are even more harder than metals. It is because of the different size of atoms. So now have a look. If this is the size, if you apply force from here, what will happen? It does not allow the layers to slide, or there is a very large amount of energy or forces needed to allow the layers to slide. Okay. So examiner asks the comparative strength of alloy and metal. So you have to answer it in this way, that alloys are relatively stronger and harder because of the different sizes of atoms present in its structure, and that makes layers difficult to slide over each other. Is this understandable?
Sir, I didn't get its definition.
Which one?
That what is actually alloy? The mixture of metals with other metals and non-metals.
Yes, for example, if you look over here, brass, it contains two metals, a zinc and a copper, right?
Yes.
So there is a metal and there is another metal. So it is a mixture of metals, right?
Yes.
But when we look at stainless steel, here we have a iron, which is a metal, chromium, which is a metal, nickel, which is a metal, and there is a non-metal as well.
Okay. Okay. Yes.
So that's what it is, that you have to know this, that it is not always there are metals in alloys. Sometimes there is some quantity of non-metal is also present along with the metal in alloys. Okay.
Okay, sir.
Yes, Rahima and Zainab, is this clear?
Yes, sir.
Yes, everyone completed?
Yes.
Yes, Zainab. Now, these are the
Sir,
yeah, sure. Here we have the uses of metals and alloys. So these are the ones which examiner can ask. Yeah. So when we talk about copper, copper is used to make electrical wires. It is because it have a better conductivity than rest of the metals and it is very ductile. When we talk about aluminium, it is used.
सर आप थोड़ा ऊपर कर सकते हैं वो मैंने कॉपी नहीं करा
Yes, sure. Okay. So when we talk about aluminium, aluminium is used in overhead cables. So see, copper is used for make electrical wires, but when it comes to overhead cables, because copper is very dense and heavy, so we cannot put a cables of copper on a poles as our overhead cables. So for that reason, we use aluminium, and aluminium is also used in aircrafts. And the reason behind is this, that it is very lightweighted and have a low density. Beside this, aluminium is also used in food containers, and you have seen aluminium foil as well, which is used to wrap the food. It is because that aluminium resists corrosion. Okay. Then we have stainless steel, an alloy of iron, and it is used in cutlery and utensils because it is very strong and does not corrode. So these are the uses of metals and alloys, and we are going to end our class over here. You guys just note it down. And in the next class, we will start with the chemical properties of metals. Okay.
Okay, sir.
Fine. Yes, if anyone of you have any issue or any confusion, do ask, please. Done. Okay.
Sir,
Yeah. Yes, Khatija.
sir, I want to ask that what is meant by resist corrosion?
Sorry.
What is mean by resist corrosion?
Resist corrosion, that it does not corrode, it does not rust. You know what rust is?
Yes, like zang lag jana, right?
Yes, yes. Corrosion is the another term for the rust. So aluminium does not rust. Just give me a minute to stop sharing.
सर हमारा हो गया तो हम जा सकते हैं
Yes, if you are done, you can leave. Okay.
ओके थैंक यू सर
You're welcome. Rahima, is this everything is clear to you as well? Okay, she also left. Okay. Khatija, are you done?
Yes, sir, done. Okay,
Okay.
sir, Allah Hafiz.
Okay, take care everyone. Allah Hafiz.